Hello.
Hello.
Yeah, I can't hear you.
Hello. Hello. Can you hear me?
Yeah, yeah.
There is a problem on my side. Hello. Hello.
Your voice is really like low.
Yes, I'm with my side. Hello. Can you talk?
Yeah, can you hear me?
Can hear you, but my headset is not working. Hello.
Yeah.
Hello.
Yeah.
Hello?
Yeah.
Hello?
Yeah.
Can you speak loudly?
Your voice is not clear at all.
Hello?
Hello?
Can you speak?
Yeah, yeah, I can hear you.
Okay. I think voice is okay now, but I don't know. Can you see my screen
No.
now?
Yeah.
I think I should continue with mobile. I have connected the audio in mobile phone and the video is on my laptop. Okay. So shall we start?
Yeah.
One second. This one, right?
Yeah.
So what do you know about this? I mean, I want to know your level, basic level. Uh, how good are you in basic digital system, computer science, microprocessor assembly, and the digital design? You know any basic terms, or how good are you?
I just need help solving these questions. That's it.
Okay, you know how to do this. You know all these basic terms like what is clock, what is LD, C, 4-bit counter, what do you mean by a counter, and
Yeah.
D, what is that? What is D here?
Load.
LD is load, that's fine. What about this? LD, D, and then bracket 3, colon 0. What is that? What do you mean by that?
The 4 bits.
4 bits of what?
4 bits starting from 48.
No, no, no. It is a data, right? It is a data for this 4-bit counter, right? Initial data of 4 bits, right? So it is a
Yeah.
4-bit counter, right? So as it is a 4-bit counter, what do you think of it actually? How many from? I mean, how many numbers it can count maximum if you start from 0? So it is
All
a
the way to
4-bit counter, right?
111. Yeah.
It is a 4-bit counter, right? So tell me, as it has a maximum of 4 bit, let's say I start from 0. 0 to how many numbers it can count? The 4-bit count.
The 1111.
1111 is what?
Uh, 1 second.
Are you there?
Yeah. It's
111 is
15.
what? What?
15.
It is, yeah, 0 to 15. So totally 16 numbers, right?
Yeah.
Right?
Yeah.
Right. So, but what is your requirement here? I mean, you should start from 48 and ends with, it should end at 239, right?
Yeah.
So 48 to 239. So tell me, how many bits needed to actually count this range? Any idea?
8 bits.
8. So
Yeah.
with 8 bit, what is the maximum number that you can count up to?
254, I think.
No. Can you be uh, precise with your answer? I think you're coming closer to the answer, but still you're
264.
no. Why? I mean, we have a formula for that, right? If it is a 8-bit number, there is obviously a direct formula to apply to get that maximum range, right?
255.
Yes. What is the formula? 2 power 8, right? 2
Yeah.
power 8 minus 1. Why minus 1? Because I start from 0, right?
Yeah.
So it's going to be 2 power 256 minus 1. 255 numbers from 0 to 250, right? So
Yeah.
my range is within that. I start from 48 to 238, right? So
Yeah.
it is very much possible with 8-bit counter. Now we have decided that we can design this with the help of 8-bit counter, right?
Mm-hmm.
So this can be confirmed. This has to be your initial instruction to the question. Now the problem is we just have 4-bit counter, right? So, but we are
Yeah.
allowed to use two 4-bit counter. Can you see this? Using two
Yeah.
4-bit counter of type shown in the below logic gates, design a binary counter that counts from decimal 48 to 239, right? Yes,
Yeah.
it is possible. Now the next one is an input initialization. When set to 1, okay, there is one input called init. Set to 1, initialize the counter synchronously to 48. Okay, so there is a kind of button or whatever. When you press it or when you set it 1, it should count from 48. It should not count from what? 0.
Yeah.
So the counter has load and counter enable. Load is what? Load is something that if there is an input, if you want to load the input to the counter, it should be done. For example, 48 is your initial value. It should be loaded to the counter, right? Right.
Yeah.
But it cannot be loaded to a 4-bit counter. It has to be loaded to your 8-bit counter. So you need to design the counter in such a way that there should be a load that should be activated to load the initial value 48. And that is why we need load here. Otherwise, why do you need load? If you start from 0, you don't need load, right?
Yeah. Yeah.
Next is count enable, right? See,
Mhm.
you have a clock, I mean, a control master. Only when you enable it, you should be able to activate the counter, right? It is like admin permission. If your counter enable is 0, then your device should be in deactivated state. It should not be working or it should not be activated. If counter
Yeah.
enable is 1, then your device should be available for the user to operate, right? So
Yeah.
4-bit counter, assume that Q3 to QD3 are the most significant bit. Yeah, we know that. And parallel inputs are respectively. That's fine. CO is the carry output. Okay. Output. What is the carry output? Why do you need that?
So when it reaches 1111, then it
Yeah.
adds another one. The
Then
one
it
goes.
has to go to the next counter, right? The output of CO should be passed to the next 4-bit counter. So you need a carry out, right? You understand
Yeah.
this? Yeah, that goes to logic 1 when the terminal counter is reached. Yeah, once 1111 is reached, it has to go to the next count, right? The LD input enables parallel load, right? And C input acts as count enable. Yeah, so the design is confirmed and it is easy. How are you going to make it? The solution is already there, but you know how to make it, right?
No, I
You
don't.
don't know. You don't understand the solution or what?
Yeah, I don't understand it.
Right.
That's why I took this class.
You don't need a brainer for this. You don't need to go internal operation for this. Just believe me. You just need to have a parallel. For example, I'll come to this. I mean, what is this LD statement? What is this LD? LD means load, right?
Can
What
you
you
can
are
we
trying
start
to load?
drawing and like going over it or no?
Sorry,
Can you start like writing, like drawing it and stuff? Show me how to do it?
this one.
Yeah.
Well, we cannot explain this because it is straightforward. If I explain this, you won't understand. We need to go deep. Hello? Are you there?
Yeah, yeah.
See, I can easily explain this like this. Okay, 0, 0, 1, 1, 0, 0, 0, 0, but you won't understand this. You need to understand how a counter is working, right? Hello?
Yeah.
Right? That is why I go here again. LD is a load command used to load input parallelly to the counter. To understand this, you need to Google it, or maybe you need to try to find out how a 4-bit counter works. Do you have a lecture for this? Any notes or something like that?
No, it
You don't
doesn't post
have
any
any
lectures.
details? You don't have any class notes? You don't have anything?
The problem is he doesn't post any lectures.
Then how can we actually expect us to complete all this, right?
I mean, I
Right?
sent this like 4 days ago.
You sent me this 4 days ago.
Yeah, many days ago.
I got it yesterday. I got it yesterday. So this is my
Can
4-bit
you
counter.
can you go back to that page?
This one.
Yeah.
Yeah, tell me.
So 1 second.
See, you are starting from stage 0, right? See, yeah. There is
No, my
stage.
question. I have a question. My question is
Yeah.
when the load is 1,
Hmm.
0,
What up?
0, 1,
0,
and
0, 0, 0 is loaded into the 4-bit counter of stage 0.
so when does the counting begin?
When you enable the clock, when C equal to 1, right? When C equal to 1, right? Hello? When you
Yeah.
make C equal to 1, the count begins. Because that is your control, right? Hello? There is a clock. Can you see that? There is a clock and
Can
there
you
is C
zoom out?
equal to 1. What?
Can you zoom out a bit?
Now fine.
No, like if you scroll down,
Hmm. Yeah.
yeah. So when Q 0, 1, 2, 3, 4, 5, 6, 7,
They see these logical gates are used to count from 49, 48 to 239. If you don't have these logical gates, where it will count now? It will count from 0, 0, 0, 0 to 1, 1, 1, 1. It will count like this. You understand this? I mean 0 to 255, right? But what do you need? What do you need? You need 48 to 239, right? Yes? Hello?
Yeah,
Yeah. And that is why you have logical gates. See here, 48 is this 00110000, right? Hello?
yeah,
This
yeah,
one, right? 239 is what? 1110, again 1111, right? Right? Yes?
yeah.
See, and your MSB bit 0011 is given in the stage one.
So my
And
question
your
is when it gets loaded, what
uh,
happens after that?
which one get loaded? Any something, right? When it gets loaded, the inputs, let's say if I load 0000, and when I try to load it, it will be there in the counter memory. Counter is a flip-flop, right? Flip-flop is a memory, right? Hello?
No, when 0000 gets loaded,
Uh,
be my output Q.
it
Q
will
zero.
be loaded, but it will not be displayed. It will not start begin counting. It will just be loaded.
So
It
when
will,
will it start
it
counting?
will sorry,
When will it start counting?
it will start counting after you pass clock signal and C equal to 1. Do you understand? Hello?
So yeah, yeah.
Yeah.
But
Hmm.
but when load is 1,
Hmm.
what happens
When
after
load
that?
is 1, your loading value will be stored. When load is 0, even if you try to load, it will not be loaded.
So when load is
Understand?
0, then it just counts? Or
Load is 0, it will not do anything. Whatever there in the value will be there. When load is 0, only when clock signal is activated and C equal to 1, it will be counted.
even if the load is 0?
Yes. It will be counted even if the load is 0, but you don't know what is the initial value in the counter, right? It will have some previous value. It will start from there. You are not loaded anything. That's fine. But it will
Okay,
have some other previously loaded value, right? It will
that's
start
okay.
from there.
Initially it's
Hmm.
0000.
Right.
Uh, can you scroll a bit down? Just a little bit. Hello? Like, can you include that? Yeah, yeah, like that. Yeah. So
Yeah.
there's two AND gates.
Yes.
So when
Why there are two AND gates and there is a bubble in Q4? Can you see that? There is a bubble
yeah,
in Q4. Why is that? Because it is 1110 and 11110 is the MSB bit of 239. Can you see that? 239 is 1110. 48 is 0001. 0011. Hello?
can you can you repeat that?
See, why it is, see, Q0 to Q7, right? There is only one bubble in Q4. Why is that? It
No,
is
my
It is because you are taking the binary pattern for 239. 239 is what? 1110 1111, right? Yes or
yeah,
not?
yeah.
And
My question is when I press init,
mm,
it becomes 1 or 0. Like at the very beginning, right?
it when you press init, the output signal, that is there is an output signal, right? Dollar sign,
No,
right?
no. When
Uh,
I press init, it's
uh,
it's 1 or 0, which is 1. So the dollar sign goes to load.
yes, it will be 48 will be loaded.
So then 48 is loaded.
Yes.
Now now uh
Now after passing the clock signal, it will be counting. Like let's say C equal to 1 and clock signal is activated, it will start counting from 48.
okay, so the clock signal that 1 second. CO1 CO is star CO. 1 second, yeah. Okay, so when when it starts counting, then it becomes 0, 0, 0, 0,
Hmm.
and that comes at the output Q3, Q2. Can you scroll? Yeah, Q1, Q0,
Hmm.
and that goes into the AND gate.
Hmm.
What about Q4, Q5, Q6, and Q7? What
That
goes there?
also goes to the AND gate, right? And the output will be according to it. For example, if it is 48 only, it will be actively high. Your
Acting what?
two AND gate are designed to get only 48. There are two AND gates, right?
I can't
Hello?
hear you.
You cannot hear me. There are two AND gates, right?
There's what?
There are two AND gates, and Q4 is bubbled, right?
Yeah, but what is Q4, Q5, Q6, and Q7?
There are output of the counter, stage one counter. Can you see this?
But
That is directly
count enable has not been turned on for that, because count for this counter on the left,
Hmm.
it's not gonna count because
Why? It will count. Why
because
it will not count?
because it's at one. Count enable carry out is connected to count enable, and that's not
So what?
one.
So what? That's not one, but at some stage after 15, it will start counting, right?
After what?
After 1111, it will start counting, right?
Yeah, but what I'm saying is when this starts at 0, 0, 0, 0,
Hmm.
the right counter, then it goes to 0, 0, 0,
Yeah.
1.
Hmm.
And then in that AND gate, it's 0, 0, 0, 1. But what goes into Q4, Q5, Q6, and Q7?
That then nothing will go to Q4, Q5, Q6, Q7 when stage zero counter is activated. Nothing will go there.
So then what will Q0, Q1, Q3, Q2, Q3 be ANDed with?
Q0, Q1, Q2, Q3 will be connected to the output of stage zero counter, right? So it will be one, the maximum value Q0, Q1, Q2, Q3 will have is 1111. After that, the control will be taken by Q4,
No,
Q5,
no, no, no,
Q6,
no.
Q7.
I know that. I'm saying when Q3, Q2, Q1, Q0, when you add 1 to 0, 0, 0, 0, it becomes 0, 0, 0, 1.
Mm.
And then zero comes out to the AND gate.
Okay.
Like, this is what I mean. Like
You are complicating it. I'll explain this way.
0, 0.
Wait. See, assume that Q3, Q4, sorry, Q2, right? Q2, Q1, and Q0 equal to 1111, right? 1111 is what? 15, right?
Yeah,
So when this comes, the output of the below and get is 1, right?
yeah.
Right? So when this is 1, but the above and get is already 0, right?
No, I'm not, I know that. I'm saying when it's 0, 0, 0, 0, 1.
Like this.
Yeah, what happens then with
Wait, wait,
this?
wait. What I'm not, wait, wait. 0, 0, 0, 1 or 0, 1. Like this.
0, 1.
Like this. Right?
This.
Yeah. This will, the output of the AND gate will be 0. And init will not be activated. And it will not start count. It will not load the value.
Okay, let me.
You understand?
No,
It will load the value only when the input is this. Only when the input is this.
wait, 1 second.
0, 0, 1, 1, 0, 0, 0, 0. Only when this happens, it will load the value.
1 second. Can you move that? Can you scroll down a bit? Yeah. So this 0, but this
What
one,
is this? 0, 0, 0, 0, 0, 0, 1 means. So what about the other outputs? Can you show me the other output? Q4, Q5, Q6, Q7.
it's now, this counter
Why?
won't be counting
It
because
is the
this
output. It should come. It will have some value. It should have some value. Give me that
this is
value.
connected to this.
It must have some value, right? It must be 0 or 1, right?
This will only be carry out will only
Anyway, it must be having some 0 value, right? Q7 must be 0 initially. Q6 0, Q5 0, Q4 0. Why you don't include that? Only when it is connected, Q1 is passed to the next stage. But initially Q7 will be 0, Q6 0, Q5 0, Q4 0. Mention that also.
so this is all 0.
Yeah, all 0.
But even when this will get loaded in here like this, but this will be 0.
See, if the load is not activated, the output is always 0, 0, 0, 0. Only when the load is activated, the output will be like that. You understand what I said? Hey, I'll explain this. Give me some time. Wait. See, it is very simple. I'll draw this and explain. Wait. Okay. I'll draw this and explain.
Yeah.
Are you on the line?
Yeah, yeah.
One second. Okay, I'll explain here itself. I cannot write here. Now, now assume that see, now assume that it is 0, 0, 0, 0, 0, 1, 1 and 0, 0, 0, 1, which is actually 48, right?
Yeah.
Yeah. So when load is activated, assume that load is activated. When load is activated, these inputs will be the output of the gates. So assume that load is activated. So the load is activated and the output comes like this. Do you understand this?
Yeah.
When load is activated, output is actually equal to input. Do you understand this? Hello?
Yeah, yeah.
Yeah, you got it right. So now the output is the input because the load is activated, clock is enabled. And this is given here. Yes or not?
0, 0, 1.
Right?
Yeah.
Right? Now what happens?
So this one becomes 0?
0. Right?
Yeah.
This is 0. And then it is 0. But initial equal to 1, right?
Yeah.
So it will come here. And 1 is given. 1 is given to what?
Load.
Load.
Yeah.
Right? And
Yeah.
that is why there is an output here. So initially, when you press 0, when you whatever you input, the output will be this, right? Hello.
So how does it start counting then? Can you draw that and show me that?
I have just loaded. Now I have to start counting it, right? I have just loaded it, right? Yes or not? I have to
Yeah.
start counting it, right? Now I got the initial value 48.
Yeah.
Right? Now it will start counting from 48, 49, 50, and goes on up to what? When it reaches 239, it has to stop, right? Yes or not?
Yeah, but my question is,
Wait. Let me complete it. What is 239? 1110, 1111, right?
yeah.
So now it will be here. 1110 will be here, right? And
Yeah.
then 1111, right? Right?
Yeah. Yeah.
So 1 here it is 1, right?
Yeah.
I will make sure that I get initialize equal to 0 here, right? Hello?
Yeah.
Right. Next, what happens? The output will become 0. Output will become 1, and I will connect this to the counter stage. It will stop counting here. 239 will be my last counter. What is your question?
My question is, initially, when I press init, are these values just 0, 0, 0, 0, 0, 0, 0, 0?
No. See here. When you press init, it should be loaded with 48. So when you press init, it should be loaded with 0011 0000. If you don't, if you just switch on the circuit, initially it will be 00000000. But when you press init, it will be 48.
Okay, and then my question is, when the
Yeah.
output here comes out as 0, 0, 1, 1, 0, 0, 0, 0. So when this output comes out and now it starts counting, this becomes 0, right? Because you only press it once.
Okay.
And 1 second. So this is 0, 0, 0, 0, 0, 1, 1.
Output is 0 in both the cases. So nothing is loaded. It will start counting.
Oh,
Output is
then it
0,
starts
nothing.
counting.
It will start counting.
So then this
So
is 0.
when it reaches 239, now write the binary for 239. What is the
That's
binary for
1, 1,
239?
1, 1, 1, 0, 1.
Write down that in the gates Q7, Q6, Q5, Q4. Can you write that?
Before I read that, I just want to ask,
Hmm.
when this is 0 and load becomes 0, how come it starts counting then?
When load is zero, when load is 0, and when you enable C equal to 1, it will start counting. That's how the counter is designed. You should understand the internal operation of the counter. Hello? When load
Yeah,
is
yeah,
0 and C equal to 1, it will start counting automatically because there is a clock signal. It will activate the counter. The counter is made up of lot of flip-flops. For example, like this. You know
yeah,
this?
yeah.
You know counter,
Default
right?
stop. Yeah, yeah.
Flip-flops. So internally, once the clock is activated, all the binary bits are traveled and according to the clock and the input data, it will start counting. Maybe you can use a T flip-flop or JK flip-flop for that. T
So
or
how come
JK
this is always one?
should be it should be made one when you want to count it. It is not always one.
But this was
This CE should be always one. CE should be one, but when you press clock, it will start counting. You understand? CE should be one.
so when this reaches 1 1 1 1 and this
Hmm.
carry out takes
Hmm. It
goes
will go
here.
there. It will go to the next stage. Yeah.
So what will happen to these values?
Which value?
These ones. Will it keep counting these or no?
It will be like this. So after that, what will happen now? It will be like this. So the Q carry is gone there, right? So it will be like this: 0, 0, 0, 1, and then 0, 0, 0, 0. The group stage 0 will all become 0. And then now you are operating with both the counter, right? Both the counter has a clock pulse. So the next count will be like this. And the next count will be like this. And after that, after some time, when you reach this stage, like let's say when you reach this stage, the carry will come, right? So the carry will come, so it will be like this, and it will become 0 again here, right?
This
And
will
again
start counting here?
it will start counting like this. Do you understand?
Yeah.
This is how it goes. You go to use both the stage. So now let's say I reach the next stage like this: 0, 0, 1, 0, and then 1, 1, 1, 1. Now what happens? The next will be 0, 0, 1, 1, 0, 0, 0, 0. Right?
Oh, okay.
Right? You understand
Yeah,
this?
yeah.
Again, it will start counting like this: 0, 0, 1. And here it will be same, right? 0, 0, 1, 1, 0, 0, 1, 0. You understand this? This is what I think got stuck.
Okay.
And let's say when you reach this stage, 0, 0, 1, 1, and this will also come, right? So in this stage, what happened? 0, 1, 0, 0, 0, 0, 0, 0. Right? It goes like this, right?
Yeah.
Finally, when you reach this stage, what is the 239 stuff? What is 239?
It's 1 1 1
1, 1,
0
1,
1
0. So 1, 1, 1, 0, 1, 1, 1, 1. This is my final output. So when I reach this stage, the circuit is given to the AND gate, right? The gate here, right? So
Yeah.
after this, I should not count. After this, it should become what? Reset, right? Do you
Yeah.
understand?
Yeah.
Right? So for this to happen, I have connected all these bits to Q7, Q6, Q5, Q4, Q3, Q2, Q1, Q0 of AND gates, and then AND gate and OR gate. That's it. Easy, right?
Okay, and when wait 1 second. So okay, when I add 1 to 0 0 0 1 1. Hello?
Yeah, yeah.
Uh what does it become?
What?
So when I add 1 to 0 0 1 1, what is the output?
Oh, 0, 0, 1, 1, right? When
Yeah.
you add 1, you get this. 0, 1, 0.
So yeah, can you put that there? Once, can you go back? So this So when this starts counting, it goes 0, 1, 0, 1.
It will count. What is that? No, it will not count like that. See, only if the stage 0 is overflow, it will increment the stage 1, right? It will not increment stage 1 straight away. Only when there is a carry from stage 0, it will increment it, right?
Yeah.
I mean, this is actually a carry from stage 0.
Wait, can you go back? So when this starts counting, this will be 0, 0, 0, 1.
Okay. It
So
will start
here,
counting from stage 0 only. What is
so
your stage 1 now?
let me finish. Let me finish. Can you scroll a little bit down? So this is 1, 0, 0, 0, and this is 1, 1, 0, 0. So this becomes 0 and this becomes 0.
Hmm.
So then this just keeps counting again.
Yeah, it will keep counting.
And how will it know when we reach 249, 239?
239. Write binary for that.
Okay. So binary for that is 1, 1, 1, 1,
Hmm.
0.
Right. Now, what is the output? Output is 1.
Yeah,
And your unit is 0, right?
yeah.
So it will go get connected to load again. So it will load 239.
Okay, and then will it go back to 49?
239. That's it. After that, what is 240? 239 is this, right? What is 240? What is 240? 240 is what?
Uh,
1110, then not, no. What is 240? 240 is this. 240 is this. I think this is your 240, right?
yeah,
Hello?
yeah, yeah.
Okay, now apply this to your gates. 11110000. Apply this.
So 1, 1.
No, 1111 on the highest. Upper 1111. The output is 0. Initial is also 0. So it will not be loaded, it will stop counting.
Okay. How does it go back to 29? 49?
39.
Yeah, how does it go back to
Why do you want to go back to 39? 239.
No, after 239, where does it go?
What?
After it goes from 48.
239 to 240, it will stop counting. 49, 48, then 29, not 293, 239.
Yeah, 239.
Now, what is your requirement actually? To and design but that counts from 48 to 239. After that, they haven't told anything, right? What should happen after 239? What is the requirement? You don't know. So you did
No,
design for that. You are not designing for that.
it goes to 239 and then it has to go
And
back
then
to.
stop. That's it. And then stop. That's it. You are not
How does
designing.
it stop?
You are not designing after that.
Okay, how
Hello.
does it stop?
Your
Yeah.
question is also not asking that. You don't want to. You don't want to waste time on that. Hello. You don't
Yeah.
want to load 48 again after 239. It is not asked, and it is a complicated circuit. You don't want to do that.
No, I mean, how does it stop counting? How does it know to stop counting after 239?
I think 239 when it comes 239, the output is 0, right? Dollar is 0, right?
Yeah, both of these are zero.
When load is zero, it will stop counting. Yes or not?
1 second. Oh, you told me when the load is zero, it starts counting.
That is initially, and assume that when CE equal to 1 and clock is enabled. When 239 is loaded, the clock is disabled. You will disable the clock, right? You will stop applying the clock. When you stop applying the clock, it will stop counting. When 239 is loaded, you will disable the clock. Clock signal is there, right? Hello?
Yeah.
You will stop giving clock pulses to the clock signal so that it will stop counting after 239. You have to decide, you have to design for that. There should be a clear input, and after 239 is reached, your clock should be disabled. A simple one. You are not designed for that. Hello?
Yeah.
This is not a complete design. Don't worry. Don't get complicated. The clock will stop counting when clock equal to zero. When load is up, load should also be zero. Right?
When it's this, first we press init, then
What?
this gets loaded, then this becomes.
Mm.
Can you scroll down?
Yeah.
Yeah, then it becomes can you scroll a
I
little
think
bit
got
up?
confused. I'll tell you the procedure. Initially, load will be 1 and your 48 will be loaded. Okay. Then
Yeah.
your clock pulse will be active. CLK is there, right? When it is active, it will start counting. Load is also 1. It will start counting. When clock pulse is active, it will start counting. When it reaches 239, your design should be like after reaching 239, you have the control signal, right? That should disable your clock. So after disabling the clock, it will stop counting. Simple. Clock is your control. Clock is your control.
Okay. Okay, so in the second step, after I press init, this is what happens, right?
Yeah. So what is this actually? 240, right?
249. I mean 48.
48. Okay. So 48, what happened?
It's gonna load is gonna be zero and it's gonna start counting.
It will start counting, but it will start counting only when CLK equal to 1. Remember, this is very important. He didn't mention that. CLK should be 1. CLK should be 1. Only then it will count.
Okay,
Only then it will count. When CLK equal to 0, it will not count.
okay,
It
can you go
doesn't
back?
matter what is load. Do you understand this?
Yeah.
This is very important. Don't worry about load. It doesn't count when CLK equal to 0. Make it
Can you
simple.
go back? So then it keeps the cycle of counting continues until it
No, no, no.
reaches.
As per the design, it will not continue. You need to design more for that. Your
No,
question
no,
is not asking that.
no. I mean from 48, it keeps counting until 239. Once it reaches 239,
Uh, you
then
have to design a circuit to disable clock signal. Once it reaches 239, you generate a signal, right? Dollar signal should be connected to clock, not only to load, but also should be connected to clock signal. And the clock should disable the circuit. Okay, it is not a complete design. It is just a overall design. That's why it got confused. Hello.
yeah. So
Clock, that should be a signal to clock signal also to deactivate the circuit. It is not a 100% complete answer.
Okay. So this becomes 1, this becomes 1, this becomes 1. So when this again becomes 1 after counting all the way till 239, then load becomes 1 again.
Yes.
And then it loads the top value back in 49.
Yeah, it does that. I don't know. Can you repeat what did you say last?
When load becomes 1,
Hmm.
then 0011 gets loaded back in, right?
Where is 0011?
Yeah.
0011 and 0000 will be loaded when load equal to 1 and clock signal is active. C equal to 1. Everything should be on. Only then it will be loaded. Hello? You
Yeah,
understand?
yeah.
Only then it will be loaded. If clock signal is 0 or if your C equal to 0, it will not be loaded even if LD equal to 0, LD equal to 1. You understand?
Yeah.
Not only LD, clock signal should be taken into account and also C.
Can you scroll down?
Inside.
More down?
You want to continue second question? What do you want?
Question B.
I mean this one.
Yeah.
Read it. Draw the hierarchy diagram that correspond to VHDL description of an arithmetical logical unit. We are going to design arithmetical logical unit using VHDL. Okay. Clearly show all the inputs, outputs of A and U, and how the components are connected with each other with the ALU input and output to create a ALU module. I mean, you are expected to design a complete ALU using VHDL. Okay. Label all inputs, output, component, and wires correctly. All labels should be correctly derived from the given VHDL description. You know what is the ALU, right? What is the ALU?
Arithmetic logic unit.
What it contains.
What's that?
What it contains. What it can do. What it can do.
Addition, subtraction. Yeah.
And logical operation.
Yeah.
You know that? Logical operation, right?
Yeah.
Where
Yeah.
where the inputs are coming from for ALU. For example, there is a ALU, right? Right?
Yeah.
Wait, let me draw it. So there is a ALU, and the ALU symbol will be like this. I forgot it. Sorry. One second. I think ALU will be like this. Right?
Yeah.
And there are two inputs. And the inputs are coming from registers. Right? Let's say if there is a A register and there is a B register, right? And
Yeah.
ALU is this. It can do several operations. And the basic operations are A plus B. And one second. A plus B and A minus B and logical operations. A for B, AR, and not operation, AP, something like this, right?
Yeah.
Right. It doesn't perform division and subtraction, I mean multiplication, because multiplication can be done by addition, repeated addition, right?
Yeah.
Division can be done by repeated subtraction. Do you understand this?
Yeah.
You know this, right? So these are all the basic. So what you need adder,
Yeah.
you need subtractor, you need logical gates for this, and the input from the register, and the output to the register, output register. So these are all the basic components, right? I don't think we have anything apart from this. Combinational circuit. So we don't need any clock signal or something. So now let's go back to the question. See here, they start from this. I mean, they are working on 8-bit ALU, and that is why see here, MI and MO 0 to 0 down to 7. What is that?
Yeah.
0 to 7 means how many bits?
8
8
bits.
bits, right? 8 bits, right? So I have 8 bits ALU. What is F? F may be some function unit or whatever. F is 2 bits. Why, what is F actually? It is very good actually. I mean, F is going to decide the type of operation that you want to do on ALU. What is that? Wait, I'll explain this. This is not a complete diagram. Anyway, I'll give you a brief. I think maybe you can take it from there. Okay, let's say.
I need to end the session. I have to go somewhere.
Sorry?
I need to end the session. I have to go somewhere.
You need to go somewhere.
1 hour today.
Yeah, fine, no issues. We can maybe stop here. Maybe we can have tomorrow or whatever.
All right. All right. Thank you.
அவங்க பிள்ளை எனக்கு தண்ணி எடுத்து